Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll find the derivative of these functions using the product rule. Now, product rule is used when a function is made up of two functions being multiplied. So the first function here is h at x equals 5x to the power 7 plus 1 in the first parentheses times x squared minus 2x. So this function is made up of this first function here, which is 5x to the power 7 plus 1 times the second function x squared minus 2x. So we can use product rule to find the derivative of this function. So as per the product rule, so the derivative of a function which is a multiple of two functions is equal to the first function times the derivative of the second function plus the derivative of the first function times the second function. So for h at x, the first step will be, so prime of h at x equals, so the first function which is 5x to the power 7 plus 1 times the derivative of the second function. So the derivative of the first term x squared is 2x using the power rule, and then the derivative of 2x is just 2. So this is as per the constant product rule and power rule. Plus, now we'll find the derivative of the first function. So the derivative of 5x to the power 7 will be 5 times 7 times x exponent 7 minus 1, which is 6. And the derivative of 1 is 0 because it's a constant times x squared minus 2x. Now we can simplify this expression. So we can distribute the terms in the parentheses using the FOIL method. So we'll multiply 5x to the power 7 with 2x, then 5x to the power 7 with negative 2, then 1 with 2x and 1 with negative 2. So we get 10 x exponent 8, then minus 10 x exponent 7, then plus 2x, and then minus 2. Now we can distribute the second pair of parentheses. So here the 0 will go away, so we are left with just 35 x exponent 6 times x squared minus 2x. Now we can distribute the parentheses. So the first four terms will stay as they are, 10x exponent 8 minus 10x exponent 7 plus 2x minus 2. Now here we can distribute 35x6 into the parentheses. So we get plus 35 x exponent 8 minus 70 x exponent 7. Now we can combine like terms. So we can combine terms with x to the power 8. So we have to do 10 plus 35. So we get 45 x exponent 8. And now we can combine the terms with x exponent 7. So negative 10, negative 70 is negative 80 x exponent 7 and then plus 2x minus 2. So this should be the derivative of the first function using the product rule. So now we can work on the second one. So I'll use a different color for that. So the second function is s at t equals t squared plus 1 times 3 minus 2t squared. So in this function, the first function is t squared plus 1. The second one is 3 minus 2t squared. So we'll use the product rule. So prime of s at t equals, so the first function t squared plus 1 times the derivative of the second function 3 minus 2t squared. Now 3 is a constant, so its derivative is 0 minus, now for 2t squared the derivative will be 2 times 2t. So the derivative of t squared is 2t using the power rule, plus the derivative of the first function. So the derivative of t squared is 2t and derivative of 1 is 0, and times 3 minus 2t squared. Now we can simplify the terms. So prime of s at t equals, so we get t squared plus 1. Now we can simplify the terms in the second parentheses. So we get negative 4t and now plus. So in the first parentheses we get 2t and in the second one we get 3 minus 2t squared. Now we can distribute the terms in the parentheses. So we can distribute negative 4t into these two terms. So we get negative 4t cubed and then negative 4t. And next we can distribute 2t into this parentheses. So 2t times 3 is plus 6t, and then 2t times negative 2t square is negative 4t cubed. And now we can combine like terms. So we can combine the t cube terms. So I got negative 8t cubed, and now I can combine negative 4t and 6t, which is equal to plus t. So this should be the final answer for the derivative of the second function s at t. Now we can find the derivative of the third function. So I can use a different color for that. F at x equals x minus 3 over x plus 3. Now as we discussed earlier, product rule is used to find the derivative of function which is a multiple of two functions. Now in f at x, we have x minus 3 divided by x plus 3. So in this case, the x minus 3 and x plus 3 are being divided, not multiplied. So the first step here is to move the x plus 3 from the denominator to the numerator to make it a multiplication of these two functions. So the first step is f at x equals x minus 3 times x plus 3 exponent negative 1. So we have to change the exponent on the denominator to negative 1. Now we can use the product rule to find its derivative. So the derivative will be, so prime of f at x, so the first function which is x minus 3 times the derivative of the second function. So here we'll start with the power rule. So we'll multiply by negative 1 and then x plus 3 and we'll subtract 1 from negative 1 times, now the derivative of the inner function. So the derivative of x plus 3 is 1 plus 0. So the derivative of x is 1 and derivative of 3 is 0 because 3 is a constant, plus now the derivative of the first function. So the derivative of x minus 3 is just 1 minus 0 because the derivative of x is 1 and since 3 is a constant, the derivative is 0 times the second function which is x plus 3 exponent negative 1. Now we can simplify this expression. So we multiply x minus 3 by negative 1, so we get negative, and then x minus 3 times x plus 3 exponent negative 2. Now in the third parentheses we get 1 plus 0, which is 1. So multiplication by 1 doesn't change anything. And then plus. So after the plus sign, 1 minus 0 is just 1. So it doesn't change the overall term. So we are just left with x plus 3 exponent negative 1. Now we can change these negative exponents into positive exponents by moving the terms to the denominator. Over x plus 3 squared and then plus 1 over x plus 3. Now we can combine these two fractions by finding a common denominator. So for that we'll multiply the second fraction by x plus 3 in the numerator and denominator. So we get prime of f at x equals negative x minus 3 over x plus 3 squared and then plus x plus 3 over x plus 3 squared. So now we have a common denominator. So now we can combine the fractions. So we get prime of f at x equals negative x minus 3 plus x plus 3 over x plus 3 squared. Now we can distribute the negative sign in the parentheses and get rid of the parentheses. So we get f prime of f at x equals negative x plus 3 plus x plus 3 over x plus 3 square. Now we can combine like terms in the numerator. So negative x and positive x cancel each other out. So we get prime of x equals 6 over x plus 3 square. So this should be the final answer for the derivative of the third function f at x. So these are the steps you have to keep in mind to solve a problem like this one. So we have to first understand what the product rule is, how is it used, and then we apply it to functions like these, which are product of two functions. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.